it's often necessary to convert between polar coordinates and Cartesian coordinates. And the way we can do this is by using the fact that the definition of a polar coordinate is x is equal to r cosine and y is equal to r sine. So right away we get two important equations to remember. X is equal to r cosine and y is equal to r sine. But there's also two other equations that will be pretty useful for us. There's x squared plus y squared equals, well, let's just plug those in. R cosine squared, R cosine all squared, R sine all squared, R squared cosine squared, R squared sine squared, and we can factor out that R squared. And cosine squared plus sine squared is 1, and anything times 1 is itself. So there is our second important equation. X squared plus y squared equals r squared. And that's just from the definition up here, but you can also draw a picture that'll convince yourself of this. If you take any old point x comma y right here and draw your right triangle, then that would be x, and that would be y, and that would be r, the distance from the origin out to the point. And of course, it's obvious if you look at the triangle that x squared plus y squared is equal to r squared. So that's another way to remember that. Finally, we need to be able to relate theta in just terms of x and y. And the way we can do that is just by doing a division. So we'll take these down here and we'll divide y by x. Y divided by x would be r sine of theta over r cosine of theta. And assuming that r is not equal to 0, we're not at this origin point right here, we can cancel and get that y over x equals the tangent of theta. And that'll help us, if we have an xy coordinate, that'll help us figure out what our theta should be. Okay, let's work on a few different examples. Okay, we're going to convert this Cartesian coordinate into a polar coordinate. So let's take a look at that. We have an x and a y. And to turn this into a polar coordinate, we're going to need to use these other two equations. X squared plus y squared is equal to r squared. And I'll just plug in. I'll get a negative 2 root 3 squared plus 2 squared is r squared. And lastly, that would be 4 times 3, root 3 gets squared, plus 4. 12 plus 4 is 16. So we know that r must be equal to plus or minus 4. Now, actually, we could use plus or minus because there's not a unique polar coordinate, it's any polar coordinate here. So in order to handle this, we'll just go ahead and assume that r is going to be equal to positive 4. All right, now what about the angle here? Well, we know that y divided by x should equal tangent of theta. So that's 2 over negative 2 root 3 is tangent of theta. So that's negative 1 over root 3 is tangent of theta. All right. To help me split this up, because I'm used to using the unit circle, I might rewrite this as sine of theta over cosine of theta. And then we need to use, we have 1 and root 3, but to put it on the unit circle, we'll have to divide both by 2. And that'll give us negative 1/2 over root 3 over 2. So our sine should be 1/2 or negative 1/2 because of that negative here, and then cosine should be root 3 over 2. And the way that we can determine which exactly angle we need to use here is, let's just go back to the original coordinate, because we know that in the original coordinate we went left and up. So we're in the second coordinate. So we know that our angle is going to be between 90 degrees, which is pi over 2, and pi radians, which is 180 degrees. And so we know that sine should be positive, and cosine should be negative because of where we are at in that coordinate. So let's take a look here. We're going to have r be positive, so we're using the actual angle out to here. And we need an angle between 90 and 180, or pi over 2 and pi, which makes sine 1/2 and cosine negative pi over 2. And that answer is going to be 5 pi over 6, which is equal to 150 degrees if you prefer. So there's my theta, and there's my r, and that gets me that the point negative 2 root 3, comma 2 is the polar coordinate 4, comma 5 pi over 6.